Can a process be frozen temporarily in Linux? I was wondering if there is a way to freeze any process for a certain amount of time. What I mean is that, is it possible for one application, probably running as root, to pause the execution of another already running process, any process, both GUI and command line, and then resume it later? In other words, I don't want certain processes to be scheduled by the Linux scheduler for a certain amount of time.
See here. There are two signals that can suspend the execution of a process. One is graceful, and one is forceful. The graceful one is SIGST, and its purpose is to nicely ask the process, if it feels like it, to please suspend execution until it receives a seed In the case of SIGST, the process can ignore SIGST and continue executing anyway, so this requires cooperation from a program that is designed to handle SIGST. The forceful one is SIGSTOP, and its purpose is to suspend all user space threads associated with that process. It is just as impossible for the process to ignore SIGSTOP as it is for it to ignore ckill. The latter kills the process forcefully. To send an arbitrary signal, including any of the ones mentioned here, you can use programs such as kill, killall, or pkill, or use the system call kill2. See your operating system's man pages for platform/architecture/version dependent details and errata regarding any of the above. Note that the word kill in all of these commands in the syscall is a bad misnomer. These commands are not designed, exclusively, to terminate processes. They can do that by sending certain ones of the signals, but signals can also be used for functionality other than terminating a process. For example, SIGSTOP only suspends the process, and it's just one of several signals that can be sent this way. To add a condition of automatically resuming the process after a period of time has elapsed, you will need to use some sort of monitoring process that remains running and sets a timer in order to wake up the monitoring process, which then in turn calls kill2 again and sends the seedcount signal to the stopped process, in order to request the kernel to resume execution. Note that Linux has several timing mechanisms with various degrees of accuracy and precision. Furthermore, if your system is very busy, your monitoring process might not get woken up until well after its timer has expired, and thus the wake-up might be delayed. If you depend on very accurate precision of suspension and resumption of the suspended process, you may need to run your monitoring program with real-time permissions. See this man page on sked_set_scheduler2 for information about making your process real-time. You can also use high-resolution timers, a feature of the Linux kernel, which is only available if your hardware provides support for them, in combination with real-time scheduling, to get very accurate, sub-millisecond precision on timing, then wake up and send the signal to resume the monitored process very quickly. You didn't indicate which technologies you are willing to use to implement this. At a bare minimum, you'll need at least bash scripting, although you won't be able to get very fine-grained timing that way. Here is a bash script, untested, so please be careful, that is just a proof of concept of your query. If you need precise timing, you'll have to write a program, probably in C, C++ or another native language, and use real-time scheduling and timers. Note that the script will end and the controlling script will terminate, but due to screen controlling the monitor process, it will continue running in the background for 10 seconds, based on the argument passed to sleep, and then wake up and continue the child process. But this will be long after the controlling script has ended. If you want to synchronously wait for the time to elapse, just emit the second call to screen and hardcode the sleep and kill into the controlling script. You can test that the process does in fact suspend by running screen rschild. After you start this script, you won't see anything on the console. Then after the timer expires, 10 seconds, it will flood your screen with base 64 data, random characters from 0 to 9 and AF. Press Ctrl+C to exit.
Yes, you can do that by sending a stop signal to a process to suspend it and then a con to continue. Usage.
If you have a suitably loose definition of freeze, you might check out the renice command. Renice allows you to alter the scheduling priority of running processes. The normal process nice value is 0. Increasing the nice value makes the process nicer, as in why don't you go first? While decreasing the nice value makes a process less nice, as in get out of my way, I'm in a hurry. The nice value range is -20 to 19. Anyone can make their own processes nicer. Only root can make a process less nice or change another user's process's niceness. If you set a process's nice value to 19, it will only run when nothing else on the system wants to. Here is an example run on my local Linux box. Use PSL and look at the neat column to see a process's nice value. Running renice +10 on the Vim process causes it to run at a lower priority. Assuming that you can stretch freeze to mean not bother anyone else on the system, you could scriptify something like remember to run it as root. Note that I took some liberties with the above PSL output to get the interesting columns to show up nicely in the little blue boxes smile.
If you want the Super Channel, please